solving ability is very important for those who are preparing for NEET, JEE, and KVPY exams. So I have decided to do some videos to improve your problem solving abilities. First, I will do some problems in magnetism. You have seen what is the dipole moment. Dipole moment is the product of the pole strength and length of the magnet. Usually length of the magnet is represented by 2L. So small m is the pole strength, 2L is the length of the magnet. Magnetic dipole moment is the product of the pole strength and length of the magnet. Now let us see a problem. A bar magnet of length L and magnetic moment M is bent in the form of an arc as shown in the figure. The new magnetic dipole moment. Before bending, magnetic moment is capital M. But here bar magnet is of length L instead of 2L. Here length of the magnet is given to be L. So magnetic dipole moment is M into L, because here length of the magnet is given to be L. Usually it will be given 2L, so M into 2L. Now here it is M into L because length of the magnet is L. Now it is bent into the form of an arc. Here it is making 60 degree. Now distance between the poles became lesser. So now you have to get this distance between the poles. Now angle 60 degree. So if it is expressed in radians, pi by 3. Then if an angle is expressed in radians, the relation is angle is equal to arc length divided by radius. Now arc length is L, radius is R. So we can get this radius. Radius is equal to, from this we can get radius is equal to L, R is equal to L divided by pi by 3. So radius is 3L by pi. Radius is 3L by pi. So this angle is 60 degree. So this radius equal, so this is 60, this will be 60. Now these two sides are equal. So this is an equilateral triangle. So this is also, it will R. In an equilateral triangle, all the three sides are equal. So distance between the poles is R. So but R is 3L by pi. Now new magnetic moment will be pole strength M, you divide by the distance between the poles. Now distance between the pole is R, but R is 3L by pi. Now M into L, that is the magnetic moment before bending. So the new magnetic moment will be 3 M into L is magnetic moment before bending. So the new magnetic moment is 3M by pi. So this is the correct option. So for solving this, you should have the idea of this relation. Angle is equal to arc by radius, and angle should be expressed in radians. In the question it is given in degree. In this problem, we have to find the velocity of an electron when it is moving in a crossed electric field and magnetic field. Here there is a capacitor. The capacitor, between the plates there is a electric field. This plate is positively charged, this plate is negatively charged. So there is an electric field acting in the downward direction. and this cross mark shows there is a magnetic field acting into the board. If an electron is moving in a straight line, it will experience a force. That force is given by Fleming's left hand rule. Forefinger in the direction of the field, middle finger in the direction of the movement of the positive charge. So positive charge will experience a force in the upward direction. That means electron will experience a force in the downward direction because the charge of the electron is negative. Now electric field in the downward direction. Then force due to the magnetic field is also in the downward direction if electron is moving that side. Suppose the electron is moving this side. If electron is moving this side, force will be in the upward direction. Positive charge will experience a force in the downward direction. Negative charge will experience a force in the upward direction. If the electron is to move in a straight line, force due to electric field EE, this is the intensity of the electric field. Intensity is the force experienced by unit positive charge. Charge on the electron is E. So this is a force due to electric field in the downward direction. When electron is moving this side, there is a force in the upward direction. That force is given by BeV. BQV sine theta, but the charge of the electron is E, then sine theta is 1 because this perpendicular movement of the electron is this side and the field is into the board, so theta is 90. Now from this we can write V is equal to E by B. Here question is to find the time taken by the electron to cross this electric field. Length of this plate is L. Then time taken is distance divided by velocity. So here charge density is sigma. So electric field E is equal to sigma by epsilon 0. Electric field E is equal to sigma by epsilon 0. So V is equal to, instead of this E, we can write sigma by epsilon 0. Then V. So time taken is L by V. T is equal to L divided by V. V is sigma by epsilon 0 B. So this can be written in the numerator. So T is equal to L epsilon 0 B by sigma. L. This is the correct option. Epsilon 0 L B by sigma. So this is the time taken by the electron moving in a straight line. Next problem. A charged particle Q is accelerated perpendicular to a magnetic field. Here this cross mark shows a magnetic field acting into the board. It is accelerated through a potential difference of V volt. Then what's the force acting on this charged particle? Magnetic Lorentz force is given by F is equal to BQV sine theta, where B is the magnetic field, Q charge of the particle, V velocity of the particle. Theta is the angle between magnetic field and velocity. Here magnetic field is acting into the board and the velocity is in this direction, so perpendicular magnetic field. So theta is 90 degree. So sine 90 is 1, so magnetic Lorentz force is BQV when charged particle is accelerated perpendicular to the field. Here charged particle is, the charge is Q, then the work done is QV, where V is the potential difference. Potential difference is the amount of work done to take a unit positive charge from one point to the other point. So potential difference is V. So work done for unit charge. So for work done for the charge Q is QV. Then it is accelerated through a potential difference. So the kinetic energy is half mv square. Here we have to get the velocity. Here capital V is the potential difference. When a charged particle is accelerated through a potential difference of V volt, it will gain kinetic energy. Kinetic energy is given by half mv square. So from this we can get an expression for velocity. V square is 2qv by m. So V will be square root of 2qv by m. Now for this velocity we can substitute bq. For this V we can write square root of 2qv by m. Now these are the four options given. So we have to make it in this form. For that, this b outside the square root, when you take inside, it will become b square 2b square q inside, q outside. This q, when it is taken inside the square root, it will be q square, and this q, so it will become q cube v by m. Square root of 2b square q cube v by m. So this is the correct option.